Hello, in this short tutorial I'd like to review our understanding of structure, and this will be the assignment for week 15 into week 16. Just a little simple program to either draw out a flowchart or do pseudocode or do both, depending on how many points you want to earn. Just as a brief overview of structure, well actually let me first show you what I want you to do. We're going to go ahead and refer back to chapter 3, and on page 118 in the book, number 9 is what I am going to want you to, the exercise that I want you to do. We're going to draw a structured flowchart or write structured pseudocode describing how to tidy up an apartment. You have to include at least 2 decisions and 2 loops to get full credit. What I'm going to do is I'm going to show you the solution for number 10, which is basically the exact same thing, but for wrapping a present. So you just kind of have to create your own ideas of things to do, and changing it up a bit would be nice too. But I just want to give you a good idea, at least, of how to do this. And we'll real quickly just go over what structure is, the 3 basic structures. I know it's been a while since we've been through it, so I'm going to flip through this chapter 3 PowerPoint pretty quickly here. This is unstructured logic. We saw this in chapter 3. We want to, the 3 basic structures, we have a sequence structure, which is just step 1, step 2, step 3 type thing. You have a decision, a selection structure. And that's going to be, yes, no, if yes, do this, if no, do this, or sometimes do nothing. As we talked about the dual alternative ifs, we have an if, then do, else, do something else. You can't have single alternative ifs that just if, then, and if else, if it's not true, then it just does nothing. It's a null case, as it says there, situation where nothing is done. So that would look very much like that. It would be if yes, then we do something. If no, then we just go on. And then the third structure is the loop, repetition, iteration. So we ask a question just like we do in a decision or selection structure, and all questions that are asked, by the way, have to have a binary result. You have to say it's true or false. It has to be yes/no questions. You probably got that pounded into you by now, but that's how computers work. It's zeros and ones. So every complex question has to be broken down to the most basic yes/no questions. So sometimes things become more complicated, but as you really get to understand the breakdown of it all, I think it, in a way, becomes easier. So, ask a question, the loop control question, and if the answer to that is yes, then we perform the body of the loop. It could be a step, any number of steps. There could be other decisions. There could be other loops or sequences within that. But something happens and is repeated, and then we go back to the beginning of that structure and then ask the question again until that is false, and then we proceed on. You can combine these in many different ways, and obviously that's just a stack of the structures. You have a sequence, and then you have a selection, and depending on yes or no, you follow one of these paths, and you come down here and you have a loop, and if it's yes, and you might do this however many times, and you go no, and you go through. But obviously that doesn't allow you to do a lot of very complicated things. So you can nest structures, and the key here is to make sure that you maintain structure and don't cause the code to be unstructured by improperly joining or nesting the structures. And this is, of course, just really it's basically the same thing as a single alternative selection structure. It's just we're expounding on the fact that we do something to say we do 3 things. I mean, it doesn't make any difference how many steps you take, but that's just as long as you understand that it's contained within that every time condition H is true, all those steps are going to be taken. Then we could also put a loop inside of that. Step 2, instead of being just another thing that we do, could be, well, do we have this other condition? And if so, then let's do this, and let's do it however many times that this is true. Otherwise, then let's just go do this other step, including the fact that the first time it goes through, it could find that that condition is false, and it could never perform this part of the loop and just go on past. But the point is, you can join the logic any way you want. And this is even getting even more complex than you'll have to do probably for the apartment, cleaning up your apartment type thing. But you can go down here and ask a question, and then based on that question, ask another question, and then go back up here. Actually, this question is, I'm sorry, this is a loop. You're entering a loop, but then when you enter the loop, you find out, yes or no, and then you go back around and do it over again. So again, you can make it as complex as you want. Actually, go back up here, and it'll help to follow the pseudocode. I'm not going to go over every little thing right now, but I think look at these, see how the two things relate, because I know a lot of you, I think, have struggled maybe with the pseudocode or have indicated that that's harder than the flowcharts, but they really directly correlate. I guess it's just maybe a visual thing, but at any rate, I'm hoping that will help you all a little bit. And here is an example of something you don't want to do. This is a functional, this logically it's sound, but it is not structured, because this is a loop right here, and the loop should always come back straight to the loop control question. Should never go above that and then come back through something. That's unstructured. So you want to make sure that, and in this case, they're showing you how to do a priming input. This is where you have to have like two of the same thing, and we've had that several times throughout the semester, have that be a problem. But at any rate, just a little bit on structure there. I'm trying to keep this short as I can. I'm already running over what I wanted to here. Real quick, I put together, just again reminding you, this is in PowerPoint. Real quick, go over what I did here. You can do this in Word, you can do this in PowerPoint. You can draw it out on a piece of paper, scan it into your computer, and send it to me. Frankly, any of those things are viable ways of completing this assignment. I think PowerPoint is probably my preferred method, but even if, well, actually, if you have Visio or something like that on your computer, that actually is built for doing this kind of thing, that's even better. I'm not picky. If you can figure out how to do it, that's fine. If you're writing pseudocode, you can write it in Word or Notepad or whatever. And like I said, you can do both, and we'll have some extra credit here. I'll get the details on that to you in an email or on the assignment page probably. Sequence, decision, again, I just wrote in my own verbiage here, true false question has to be true or false. You take, if the answer is no, you take some action or inaction. Maybe you do nothing. If the answer is yes, then you take some action or inaction. And then the loop, again, you have a loop control question, and if it's yes, then you take some action or actions, and then go back around, and if no, then you go on. And this, I just very simply nested a sequence and a loop inside of a decision or selection. If it was yes, then you did a sequence. If it was no, then you did or potentially did a loop, and then you went on. So again, these are structured, even though they're nested like this, but keep in mind, each of these structures are completely nested within this. There's no short-circuiting the logic. So I'll get past that one here, and then this is the number 10 in the solution that the publisher provided, actually. Here's the pseudocode, and here's the flowchart. So just real quick here, I'm going to try to wrap up here, but wrapping paper, sorry. Okay. We start, and I did not, sorry, let me jump back here real quick. When I was creating these, what I want you to do to get this sort of result, if you're going to do this in PowerPoint, I think in Word it's very much the same. do a new slide here real quick, and when you go to insert, you go to shapes, and then you have flowchart shapes down here. You have a terminator, or actually I think it's yeah, right there is a terminator, and that's going to be like your start and your stop, and you can draw that on here. You can draw the process, which is, you know, your square boxes there, rectangle boxes, and then you can put in your decisions, which are the diamonds, are decisions, and then you can use these connectors, elbow connectors, or just regular line connectors, curved arrow connector, any of these different ones to connect your different shapes and stuff. So like I said, I'm not too worried as long as I can tell you're getting things right. If you're not perfect on drawing it all out, that's okay, but just do the best you can if you would. It's not going to be due this week, it's going to be due next week, so that's kind of why I'm stretching it out, give you time to work on it, think about it, email me if you have questions, send me what you have so far, that kind of thing. Back to this, you know, start, we unroll the wrapping paper, then we want to see, and this is a while loop, so pseudocode while wrapping paper is too small, unrolled wrapping paper is too small for the gift. While that's true, unroll more paper. And while, if paper needs to be cut from roll, then cut paper. And, you know, on through these steps here. I'm not going to get into all the details of all this because it doesn't really matter, and you can see this on my screen well enough here. Let me scroll down through here. Just kind of let you, if you want to spend a little bit more time with this, you can pause the video at a point here and go through this. But hopefully this helps you see how the flowcharts and the pseudocode can correlate. And this does, this the pseudocode and this flowchart do meet the requirements. We have a loop here. We have a decision or selection structure here. We have another loop here. And notice this one's backwards. This one, if it's no, it actually loops. And then we have another decision or selection structure here. And so remember, there's supposed to be 2 of each. And as long as you at least meet that, that's fine. Again, I don't expect you to copy this. I expect you to come up with some ideas, and that's why I said it's got to be the number 9, tidy up the apartment. And you know, let me know how it is. I just want to offer some other way for you to get some credit and kind of reinforce what we've been trying to go over this semester. And so that'll be the main thing in week 15, and it will be due at the end of week 16. But if you can get it done this week, that would be great. If you want to email it to me, let me know how it's going. If you have questions, I can help you with them. So next week we can make sure this is all good. Thank you for your patience in watching this video.